So, Assalamualaikum. This is your Thermodynamics 2 class. So, can anyone confirm what's appear on the screen right now?
Sir, we are seeing the slide lecture 12.
Okay, thank you so much. Okay, so this is your lecture number 12. Again, it is from gas power cycle. So, in the previous class, we already discussed about diesel cycle and how to find out different parameters which are related to diesel cycle efficiency and different Q in and Q out. Okay, so in this class also we will just practice some problem which is also related to diesel cycle. Okay, and we will try to solve some uh, how to find other parameters which are also related to diesel cycle. Okay, so first you have to read the statement of this problem. So an air standard diesel cycle, okay, has a compression ratio of 18.2. Air is 20 degrees Celsius and 60 kilopascal at the beginning of compression process. It means that temperature 1 and pressure 1 is given in the question, and 1300 degrees C at the end of heat addition process. It means that your temperature at point number 3 is given in the question also. Account for the constant specific heat with temperature. Determine the cutoff ratio. So here we have to find RC, which is the ratio of the volume at your cutoff point to your minimum volume, which is volume at your TDC. The heat rejection per unit mass and thermal efficiency. Okay, so this is the question which we have to solve. So we will see that how to solve this type of question. You can note down the data from this question, then I will move towards the next one. Okay, so starting from the PV diagram first. So an important observation which I see in the assignments which I assigned during the lectures, that most of the students draw the wrong PV and TS diagram in the problems. So try to practice it, because if you do the similar mistake in the papers, it will be in the negative marking as well. So if there will be a constant pressure process, it's mean that it will be a straight line. Okay, most of the student in the previous class they make a wrong line of constant pressure, so which represent that they have no idea how to draw the PV diagram of the diesel cycle. Okay, so in order to find the different state points, so we already know that the point number 1 and point number 2, there will be a compression process. So for compression process, there will be a decrease in volume. Okay, so this point will be over there. Okay, and after compression there will be a constant pressure heat addition process in the diesel cycle. So it's mean that the point of 2 and 3 will be on a same line. Okay, and then there will be a expansion process. Okay, and expansion process there will be a increase in volume. So it's mean that and the volume of point number 4 is equal to point number 1. Okay, because there will be constant volume heat rejection as well. So it's mean that the volume for your point number 4 and point number 1 is aligned. Okay, and then there will be a 4 to 1, it will be a constant volume heat rejection process. Okay, so always try to draw the TS diagram, PV diagram, right. Okay, so because then you can solve the problem easily as well. This is your Q in, this is the expansion process, and this is the compression process. Okay, so starting from the data which is available in your question, so temperature 1 is given in the question, which is 20 degrees Celsius, so it's mean 293 Kelvin. Pressure at 1 is also given at the start of compression process, kilopascal, and at the end of heat addition process is T3, which is also given as 1300 degrees Celsius, which turned out to be 1573 Kelvin if you convert into the Kelvin. And then the compression ratio is also given, which is V1 over V2 is equal to 18.2. Okay, so for the part A, we have to find RC. So RC is equal to V3 over V2. Okay, so in order to find this, we have to first find the temperature of point number 2, because T1 is known to us. So T2, so we have to apply the isentropic relation, which is valid for your process 1 to 2, V1 over V2. specific heat ratio minus 1, and T2 is equal to, so T1 is given in the question, which is 293 Kelvin. V1 or V2 is the compression ratio, so it is 18.2. K minus 1, 1.4 is the specific heat ratio, minus 1 for air. Okay, now you can just solve it and you will get the value of T2 as 939.2 Kelvin. Okay, so our main interest is to find this ratio. Okay, so you have to apply some relation between 0.3 and 2 in order to find this relation. So we already know the relation which is valid is P3V3 over T3 is equal to P2V2 over T2. Okay, and from here you already noticed that P3 is equal to P2 because it is a constant pressure heat addition process, so it's already eliminated. And then from here we can easily find V3 over V2, which is your RC, sorry, it is RC, and then T3 over T2. Okay, so from this relation we can say that RC value is equal to 1573 Kelvin over T2 value is 939.2 Kelvin, and you can just divide it and you will get the value of 1.674 for your RC. Okay, so this is the process if there would be in the question it is asked to find the cutoff ratio. Okay, so you can solve the cutoff problem like this. Okay, so you can note it down, then I will move towards the next part.
वैल्यू लाइक टेबल से देखी थी.
K की वैल्यू आपको याद होनी चाहिए कि एयर की 1.4 है, अगर नहीं याद है तो A2 टेबल पे आप जा सकते हैं, A2 टेबल पे आप नोट कर लें.
ओके सर.
So moving towards part number B. So in part number B, we have to find the heat rejection at in per unit mass. Okay, so it's mean that we have to find Q out. Okay, so first I will see that what is the B part. Okay, so heat rejection per unit mass. Okay, and you can correlate with this PV diagram so that you will get the clear idea of it. Okay, so B part. So you already know that Q out is equal to CV because it is a constant volume heat rejection process, T4 minus T1. Okay, so T1 is already given in the question, so T4 we have to find, and in order to find T4, so either you can apply the relation between isentropic process for 3 to 4 in order to find the state property, temperature property at point number 4. So we already know the relation T4 over T3 is equal to V3 over V4 K minus 1. Okay, so from here you already know that your cutoff ratio is V3 over V2, and you can say V3 is equal to RC V2. Okay, and you can put this value in, you can say it is number 1, equation number 1, and you can just put the value of RC V2 over V4. Okay, and K minus 1, and if you can notice over there that V4 is equal to V1 from this PV diagram, so it's mean that if you can just put this V2 in the denominator, so it turns out to be V1 over V2 because V4 is equal to V1, so that equation will be RC over compression ratio K minus 1. Okay, so now these two values are known to you. RC value is given in the previous section because we already find the part A, and R value is given in the problem. Okay, so you can just, and T3 value is also known to us from the question as well because it is mentioned at the end of heat addition process the temperature is 1300 degrees Celsius. Okay, so you can just put the value 1573 which is the temperature at T3. RC value is 1.674, which is given from part number A, and then 18.2 is the compression ratio, and 0.4 1.4 minus 1. Okay, so from here you can easily find the temperature at point number 4. So T4 is equal to 605.6 Kelvin. Okay, so now you can put this value in, you can say it is equation number 2, the equation number 2, and you will get the CV value. You can either remember it or you can go to table A2 and you can find 0.718 is the value, and T4 is 605.6, and T1 is mentioned in the question, which is 293 Kelvin. Okay, so from here you can just solve it and you will get the value of Q out as kilojoule per kg. Okay, so this is the part number B. So now you can note it down, then we'll move towards the next part.
तो CPCV की भी वैल्यूज याद रखें हम।
CP और CV की वैल्यू वैसे तो याद होनी चाहिए, 0.718 है CV की और CP 1.005, but if you do not remember it you can just because table A2 is given in your exam as well, तो उसमें याद करने का कोई इशू नहीं है उसको,
ओके सर।
तो वहाँ से आप ले सकते हैं। Okay, so coming towards part number C, which is to find the efficiency. So efficiency is equal to 1 minus Q out over Q in. Okay, so Q out you already find, so Q in you can find it easily because it is a constant pressure process, so T3 minus T2, and CP value, because T3 is known to us from the previous section and T2 is also known to us. CP value you can just go and find in table A2, and T3 is 1573 and T2 is 939.2. Okay, and from here you can just solve it and you will get 636.9. And for efficiency you can just because Q out is from part number B, so 224.46 is the Q out and Q in is 636.9, and you can just get the 1 point minus 0.35, and that turned out to be 65%. Okay, so here you also use the equation which we already derived, which is the function of compression ratio and cutoff ratio. Okay, so in the previous lecture, so you can also use that equation because R and RC value is known to us and K value is also known to us, so you can easily find the efficiency for the constant specific heat case, but only for the constant specific heat case. It is not valid for the variable specific heat. Okay, so you can find out from either this way or either this way. You can note it down, then I'll move towards the next question. Okay, so coming towards the next question, so you have to read the statement first. So a four-cylinder, two-stroke, 2.4 liter diesel engine. Okay, so whenever it is mentioned that the volume of the diesel engine is this, so it's mean that the maximum volume we are talking about here. So it is the volume at your BDC, okay, V1, which is so that's why we can just represent it with the liter, and you can just convert into other units in order to do the thermodynamic analysis. That operates on a ideal diesel cycle, has a compression ratio of 17 and a cutoff ratio of 2.2. Air is at 55 and 97 kilopascal. At the beginning of the compression process, T1, P1 is given. Using the cold air standard assumption, it's mean constant specific heat, determine how much power the engine will deliver at 1500 rpm. Okay, so here the important point is that it is mentioned two-stroke diesel engine. Okay, so if you can remember that in lecture number 9, I think I have mentioned that whenever it is two-stroke, so in two-stroke, one cycle is equal to one revolution of your crankshaft. Okay, and in four-stroke, one cycle produce two revolutions. Okay, so this you have to remember it, because okay, how much revolution in the two-stroke and how much revolution in this one cycle for four-stroke. Okay, because this data we have to use in this equation in this problem as well, so you have the understanding of it. Okay, so now starting to solve the question. Okay, so you have to correlate with the PV diagram, because it is a diesel cycle, so PV diagram is the same. Okay, so now coming towards the required thing is to find the power produced. Okay, so for power produced, you can either represent with W dot net, okay, because it is the power, and then you can just, this is n is the revolution per second, and W net, which is the total work produced from your cycle. Okay, and then you have to divide it with the, you can say it is R. Okay, so here n you can get from the, because it mentioned in the question that 1500 rpm. Okay, so you have to convert rpm into revolution per second, and you will get the value of n. W net you can find from q in minus q out, and R is the revolutions per second, how much revolution in your uh, if there will be two strokes. So I already mentioned, if two stroke it is a one value, if it is a four stroke it is a 2. Okay, so here it is 1, so it's mean that your equation to find out the power turns out to be only n into W net. Okay, so starting from the, again we have to find the temperature at all the states in order to find q in and q out. Okay, so we have to apply the isentropic equation for isentropic process between 1 and 2, and it turns out to be v1 over v2 k minus 1, because we are interested in to find the q in and q out. Okay, so here you can say it will be T2 is equal to 328 Kelvin. V1 over V2 is the compression ratio, which is given in the question 17, and K minus 1 is 1.4 minus 1. Okay, so from here you can easily find the temperature at point number 2. Okay, so now we have to find the T3 as well. Okay, and in order to find the T3, we have to apply some relation between point number 3 and 2. So P3 V3 over T3 is equal to P2 V2 over T2, and you can just eliminate this P2 and P3 because it is a constant pressure heat addition process, and from here you can easily find the temperature at point number 3, which is equal to V3 over V2, and V3 over V2 is the RC value, which is also given in your question, which is 2.2, and T3 is equal to, so T2 value come from here, so 1019 Kelvin. V3 or V2 is come from your problem statement 2.2. Okay, you can just multiply it and you will get the value of T3, which is Kelvin. Okay, so this is the temperature at point number 3. You can note it down, then I'll move towards the next part. Okay, so now T3 is known to us. Now we have to find the T4 as well. Okay, so T4 we have to apply some relation between 4 and 3. So we know the isentropic relation between 4 and 3 turns out to be T4 over T3, V3 over V4, specific heat ratio minus 1. Okay, so from here T4 is equal to T3, and you already know that RC is equal to V3 over V2, and V3 is equal to, so RC value is given in your question, so 2.2 into V2. Okay, so you can put this V3 value in equation number 1, you can say, and this turns out to be 2.2 V2 over V4 K minus 1. Okay, so as you already know that if you can just move this to the denominator of V4, it turns out to be compression ratio. Okay, so from here you can just put the value of T3 2241 2.2, and in the denominator it will be the compression ratio which is given in your question, and from here 1.4 minus 1. Okay, so this turns out to be 989.2 Kelvin of your T4. Okay, so now in the question it is okay, so once I mentioned in the initial stage of this problem that your power is equal to number of revolution into W net. Okay, so this W net is in kilojoule. Okay, so in the previous example we have to find in the kilojoule per kg, so it's mean that we have to find the mass fraction as well of the working fluid. So M is equal to P1 V1 over RT1. So P1 value is known to us from the question, so P1 value is 97 kilopascal. Okay, V1 is from your question, it is mentioned 2.4 liter diesel engine. Okay, so which is your maximum volume is 0.24 meter cube. So you have to convert 2 liter into meter cube and you will get 0.0024. And then the constant R is the gas constant, and you can easily find out this value from table A2 87, and T1 value is 328 Kelvin. Okay, so from here you will get the mass fraction of the working fluid. So M is equal to 2.473 into 10 raised to power minus 3 kg. Okay, so this is M. You have to note it down, then I'll move towards the next part. Okay, so in order to find Q in, because we have to find W net, so its equation is MCP T3 minus T2, because it is in kilojoules, so we have to multiply the mass fraction as well. So mass fraction we already find, so 2.473 into 10 raised to power minus 3 kg. Cp value is known to us from table A2, or either you can remember it, 1.005. T3 value is already known to us from the previous steps, that 2241, and T2 value also we have find in the previous steps. Okay, so you can just solve it and you will get the value 3.038 kilojoule. This is your Q in. And now we have to find Q out as well. So Q out is the constant volume heat rejection process. So CV T4 minus T1. So again you have to put all the value. CV value is 0.718. T4 value is 989.2 Kelvin, and T1 value is 328, which is mentioned in your problem statement as well. So from here you can easily find the Q out as 1.174 kilojoule. Okay, so our main interest is to find W net, which is the total work produced during this cycle is 3.038 just Q in minus Q out 1.174 kilojoule, and you can just subtract it and you will get the value 1.864 kilojoule. Okay, so now from here we can easily find the power. You can either say P as well. Okay, so N is the revolutions per second. Okay, so N value comes from your RPM, 1500 RPM. You can divide it with 60 and convert it into the revolution per second. And W net is 1.864. Okay, now you can just multiply these two terms and you will get the power of your engine, kilowatt. Okay, so from this problem you can easily find the total power produced by your diesel cycle when it is a two-stroke. If it is a four-stroke, then definitely you have to divide the revolutions which is produced by your cycle for the four-stroke engine. Okay, and if you can just notice over there, if there will be a four-stroke, it will be divided by 2. Okay, so it's mean that in your four-stroke it will be less power produced during the cycle. So this is the main advantage of the two-stroke as comparison to four-stroke, that it produce the two-stroke produce more power in comparison to the four-stroke. But at the same time, if we produce more power during the cycle, so it's mean that there will be more wear and tear in the two-stroke as comparison to the four-stroke engine, and that's why four-stroke engines are more reliable and durable, because it produces less power in the cycle. Okay, but at the same time it is not related to the efficiency, because power is something else and efficiency is something else. So it's mean that if you can just compare the two-stroke and four-stroke engine in order to find the efficiency, you will find out that the four-stroke engine are more efficient as comparison to the two-stroke engines. Okay, so this is the question. If you have any question, you can also ask me. I think it is a simple question. So you can note it down, then I'll move towards the next slide. Okay, so now the question which you have to solve. Okay, so it is a similar question which I already solved in the previous slide. So only the data is different. So here it is 3.0 liter diesel engine, two-stroke as well. Compression ratio is given, cutoff ratio is given, initial temperature and pressure at T1 and P1 is given. Constant specific heat ratio value you have to use, determine how much power the engine will deliver at 1700 RPM. Okay, so again you will get 0.2 absolute mark for all the students who will present, uh, who will send me a clear presentation of their work. Okay, so if you have any question, you can ask me, or you can note down the question as well. And again, you have to send it to me by tonight, and also you can send it to me by tomorrow. There will be no issue. Okay, if you try to understand the question during that time, it will be beneficial for you as well.